Part B, we want to get a dihedral angle between the planes ABCD and BCEF. So again, BC is the line of intersection. So I will start off by projecting perpendicular to the line of intersection from plan. Before I do so, I just forgot in the last part to bring down the point A to position in plan. So there's the point A, which we found. So it's on that line in line with the point D. So there we go. So just harden that in and then immediately start into part C. Okay, so that's the elevation and plan finished. So now we know that the line BC is at this 75-degree angle, 65-degree angle, I should say, because if that's 25 degrees, this has to be 65 degrees. So I'm going to project all the points out at that angle. You could choose to go down in this direction here or up in this direction. So I'm going to choose to project up in this direction. So as I'm projecting these up, I'm just looking at the heights and elevation so I know how far to take the lines, but you can take them as far as you want. These are construction lines, so it doesn't matter where you draw them. So I'm going to draw an X1, Y1 line perpendicular to those projection angles. So that would be my X1, Y1 line. And I'm going to take my distances from two views back. All right, now, again, in this case, I know all of my heights from elevation, so I'm just going to mark them accurately with dimensions. So I know, so for example, this line belongs to the point E and F. So if I go back one view, two views, E has a height of 0. So therefore, on that line, that's point E. And F has a height of 50, two views back. So I'm just going to measure up 50. There's the point F. So for this line here, this line belongs to the point D. D has a height of 0. So height of 0. This line here belongs to point C. C has a height of 0. This line belongs to point A. A has a height of 60 in elevation. And then finally, this line belongs to B. B has a height of 85. So always take your distances from two views back. Okay, now remember, I'll start off with the line of intersection. The line of intersection is B to C. And visualization doesn't matter at this stage, some of it would be hidden detail, some of it would be hardened in. As I look in from this direction here, I'm actually going to see a true shape of the surface BCEF. So I'm just going to harden that. So there's BC, C to E, E up to F, and F up to B. Right, so that's actually a true shape of that surface because it's an edge view and I'm looking perpendicular to the edge view, so that's a true shape. And technically then A, B, C, D is behind that. So if you were to work with the visualization, that should be hidden detail. But you don't have to focus on the hidden detail in this question, so we can just harden that in. But technically, that would have been hidden detail of if we were doing this question in the past, okay? So that's the first part of this drawing complete. The only reason we did that was to get a true length of the line BC, and we now have that, okay? Next part, I'm going to move over here. I'm actually running out of space here, so I'm going to project this across over here and draw the dihedral angle over in this side of the page. I don't like usually projecting across the drawing, but this is quite a big drawing and I haven't left a lot of space for it, so I'm just going to have to do that. No. So I'm just going to project everything over in line with my true length BC. A and D are not on the same line, but they're very close. Okay, I'm going to project or draw an X2, Y2 line now. And again, the X2, Y2 line will always be perpendicular to the projection of that view. So this is my X2, y2 line. Again, just like the last drawing, you take your distances from 2 views back. So for this drawing, I'm going to go back 1 view, 2 views. Now this is quite a big XY line. So I'm going to use this line here because this line is parallel to this construction line. I'm going to use this as a datum for my X2, Y2 auxiliary. So if I want this line here, so I want a distance for that line, I go back. So that's belonging to B and C. So I go back to another view, you can see the distance from my datum to B and C is the same distance. And I know that's 50 millimeters because that's the distance I drew in the plan. So, sorry, 55. Yep, so I'm just going to measure on the BC line out 55 millimeters. So point B and C are both out 55 millimeters. So I'm going to mark that B comma C 55 mil. Next line belongs to point A. Go back to the second view. A is on the datum line, so therefore A has a height of 0. Okay. Next line belongs to point D. D is also on that line, so D has a height of 0. Next one belongs to E. E has this distance here also of 55. And F also has a distance of 55 mil. Now, so if I want to draw that, so AB, and again, they're actually in the same point. So AB, CD, so sometimes if your drawing isn't exactly accurate, you'll take a line of best fit. So my points are about 1.5 millimeters away, so I'm just going to split the difference. That should be an edge view of the plane. And then that would mean that E, F, B, and C should all perfectly line up, which they do. So therefore, that's the edge view of ABCD. This is the edge view of BCEF. That is the dihedral angle between the planes. So mark that in with sharp arrowheads. And I'll use the symbol theta. And 4 millimeter block capitals, so just below it here, say. I'll say in block capitals theta equals dihedral angle. But just to be very clear about it, that is the solution to part B.